Hello, in this video, I will explain to you on how to solve this problem. Number 81, in figure 2559, the battery EMF is 6 volt and R is 0.5 ohm. The rate of Joule heating in R is 8 watt. Okay, let's label all in the circuit. So we will have the EMF of this battery is 6 volt. Good. And then this R here is 0.5 ohm. And then the rate of Joule heating in R is 8 watt. Okay, so we will have the power dissipated by this resistor here is 8 watt. So we'll have the power is 8 watt. Good. And the question is, A, what is the current in the circuit? Okay, so the current that passed through this resistor is, I assume it has to be here. And I will label this as I, right? Okay, so for the question A, I think we can just use the fact that the power dissipated by this resistor is 8 watt. Why? Because P, or the power, is just I squared multiplied by the resistance. Okay, and the only unknown factor here is I squared, right? Because we know that the power is 8 watt, so I have 8, and that will be I squared here multiplied by the resistance here, which is 0.5. Okay, and so we can have I squared there is equal to 8 divided by 0.5, that will be 16. And so we will have I here is equal to either 4 ampere or I is equal to minus 4 ampere. Okay, depending on where the direction of the current here. Okay, good. But then we need to find out the potential difference across R. So if we assume that this one is positive here, so I will have 4 ampere, we will have the positive sign is here where the current comes from, and where the current goes to is here. So I'll have minus sign here. And so we will have this one here. Remember that the voltage using Ohm's law is equal to I times R. Good. Now we know that I is 4 ampere and the R here is 0.5. Okay, so we have 0.5, and that will equal to P is equal to, I think this one will be 2 volt. Good. And that is the potential difference across R. So P is equal to 2 volt. Good. Now, what we need to do is to use the Kirchhoff loop rule to find out this R here, right? So what can we do from here? This circuit here form a loop, right? So we will have this loop here. So let's name this loop here as loop 1. Okay, and we can use the Kirchhoff junction rule at loop 1. Okay, but before we are doing the loop rule, we know that this current here is in series, right? So we will have this one here goes up like that. That is also I. But then we can label this resistor here. So this one will be the positive one where the current comes from, and where the current goes to is the negative sign. Okay, so for the question C, we can use the junction rule at loop 1. Not the junction rule. We need to do the loop rule at loop 1. Okay, and loop rule said that the sum of the voltage in a loop will equal to 0. Good. Let's start from this battery here, and the loop entering from the negative terminal. So I will have minus 6. I have minus, and then 6 here. And then here we move on to this resistor here. The loop entering from the positive terminal. So I will have plus. And then for getting the voltage, I can get by multiplying the current by resistance. So I will have R multiplied by I. And then plus, again, we have this resistor here. And the current, the loop is entering from positive terminal. So we have positive sign. And we have 0.5 ohm here. But that is resistance. We need to multiply it by the current. And all of that will equal to 0. Now we can just plug this I is equal to 4, right? So we have minus 6 plus 4R, and then plus 0.5 multiplied by 4. All of that will equal to 0. So we'll have minus 6 plus 4R, and then plus 0.5 times 4 is 2, and that will equal to 0. So we'll have 4R minus 4 is equal to 0. And so we'll have 4R is equal to 4. And so we will have R is equal to 1. And the unit here will be in ohm. And that is the resistance, the internal resistance of the battery, small r. And I think that's all for this problem. Okay, and by the way, you can check that this minus 4A here will be wrong. Why? Because you will have the negative value of small r. You can check it by yourself. So here the answer is the I is 4 ampere, P is 2 volt, and R is 1 ohm. And I think that's all for the problem. And thank you for watching. And if you got any questions, send me your problem to this email, rdsatria11@gmail.com. Thank you for watching and see you in the next video. Bye bye.